We will discuss lines in the upcoming videos as a part of analytical geometry problems. Other than lines, the parabolas are one of the most important and primitive curves, so we have to explore the properties of parabolas. The most basic form of parabolas is going to be y is equal to x squared. A function f of x is equal to x squared. So you can draw the graph of this function as the following parabola. All other parabolas are going to be transformation of this parabola. For example, x squared plus 2 is a parabola where you just move this parabola 2 units up, so 2 units upwards shift. Or the parabola where you have y is equal to 2x squared plus 2. 2x squared, this coefficient means that you are squeezing the parabola twice. So the parabola now, it is going to be a little bit close, twice as close as this one. So plus 2 is 2 units upwards shift. So I'm going to do the parabola like this. It's more closed and 2 units shifted up. So that's the parabola of 2x squared plus 2. We will explore graph transformations in the future, but for now we need to know that this free term is shifting the graph upwards and downwards. So plus 2 shifted the graph 2 units up. If I had minus 4, this would have shifted the graph 4 units downwards. For example, say negative 4, it would have shifted the graph here. So that's the only thing we need to know for now. So let's draw the following parabola. When you are drawing parabola, it's good to denote 4 very important points of parabola. When drawing a parabola, you should show the intersection points of the parabola with y-axis and x-axis and vertex of the parabola. Intersection with y and x-axis are going to be roots. So if you solve this, set this equal to 0 and solve it as a quadratic equation, you'll get that x1 is 2, x2 is 6. So we have 0.2, 0.6. The parabola is going to be passing through this point. These 2 points are called x-intercepts. So it's a point where y is equal to 0. So here y is equal to 0. Now we need to find y-intercept of a function. Functions will have only one y-intercept points. So it's a point where x is equal to 0. So just set x is equal to 0. You'll get 2 minus 0, 2 minus 6. So you'll get y is negative 12. So let's say this is negative 12. So this is going to be y-intercept of the function. So when you draw the graph, it should be passing through these 3 points. So let's try. So if you want to draw parabola is going to be either facing upwards or downwards. In this case, it looks like it will be facing downwards and passing through these 3 points. So it's very important. It's also important to find the coordinates of this point. So this is a vertex of parabola, and the formula for the vertex of the parabola, the x coordinate xv is minus b over 2a. Or this vertex point is in the middle of the 2 roots. So x1 plus x2 over 2. So let's say we have 2 here and 6 here. In between, in the middle, we have 3, 4, 5. So in the middle, we have 4. So the x coordinate of this is 4. To find y coordinate, you can plug 4 into this equation and get, so 2 minus 4, 4 minus 2. So that's also 4. So summarizing, we have 4 main important points of parabolas. So one y-intercept, usually 2 x-intercepts. So sometimes it's 1, sometimes 0, depending on how many roots this quadratic function have, and 1 vertex. If you are asked to draw parabola, you should show all these 4 points and connect them with one parabola. Okay, let's find all 4 points of this parabola. So first, let's start with y-intercept. Y-intercept means that x is equal to 0. If you set x is equal to 0, y is going to be negative 0. So, and x-intercept. X-intercept is when y is equal to 0 or roots of the equation. So solve this quadratic equation, which is x plus 5, x minus 4. So you can factorize it like this. So x1 is negative 5, x2 is 4. These are the roots of x-intercepts of the quadratic of the parabola. Now let's find xv, vertex. The vertex is going to be in the middle of negative 5 and 4. So you can do that by adding them and dividing by 2, which is negative 1 over 2. Graph is going to be something like this. X-intercept is at negative 20. So it's at negative 20. We have two more so this is y-intercept. We have two more x-intercepts, which are negative 5 and 4. And vertex is at negative 1 over 2. So vertex is going to be somewhere here. If you connect all these 4 points, you find some parabola like this. So this part of the parabola has become, in my case, a little bit pointy, but it has to be parabola. Now let's solve some problems related to properties of parabolas. So the question is the following. If this 1 and negative 2 is a vertex of this quadratic function, then find p and q. So how do we find p and q? Recall from Vieta's theorem that x1 plus x2, sum of roots, was negative p. And from previous problem, what was the xv? Was the in the middle of x1 and x2, which is x1, x2 over 2. So that is x1 plus x2 over 2. So that's 1 in our problem. Since we know that x1 and x2, sum of them is negative p, we get negative p over 2 is 1, or p is negative 2. So we know the value of p, so y, the function, which means the function looks like y is equal to x squared minus 2x plus q. So in order to find q, you can plug this vertex point because it's a point on the parabola. When you plug this point into parabola, you should get equality. So if I plug y is negative 2, x is 1, and we don't know q, this equality should hold. And then this negative 2 and this negative 2 on both sides cancel out, and q is negative 1. So that means my parabola is x squared minus 2x minus 1. So p is negative 2, q is negative 1. And final question about parabolas is the following. This point M is a vertex and point N is y-intercept. Find ABC. If you plug both points into this parabola, equation should hold. For example, if I plug x equals 0, y is negative 4, a times 0 squared plus b times 0 plus c, this equality should hold. Since these two are multiplied by 0, c is going to be negative 4. So we know the value of c. Okay, now let's find a and b. So I'm going to rewrite the function as y is equal to a x squared plus bx minus 4. So if I plug negative 1, I should get negative 7. So that means negative 7 is a multiplied by negative 1 squared plus b times negative 1 minus 4. Let's simplify the expression first. That's a minus b. A minus b. If you add 4 to the both sides, you'll get negative 3. So a minus b is negative 3. But this is not the exact a values of a and b. We just know that difference of a and b is negative 3. To find exact values of a and b, we are going to use the fact that M is a vertex. So which means x vertex was x1 plus x2 over 2, right? Which is the sum of roots using Vieta's theorem x1 plus x2 was minus b over a. So let me replace x1 and x2 with minus b over a minus b over 2a with this 2 divided. Also, we know that xv is negative 1. So which means b over 2a is 1. Cancel out these negatives. Or b is 2a. Combining this and this equations, we can find values of a and b. For example, plugging b is equal to 2a into this equation, because b is 2a, is negative 3. Negative a is negative 3. So a is 3. Since a is 3, b is going to be 6. So we know all three values of a, b, c. A is 3, b is 6, and c is negative 4. So this was a set of problems about parabolas. We are going to explore functions more in section function transformations.